prior to that, let me go through working with projects. So let me open up a project. I'm actually going to open up our real project that the adult working group did in their first competition. It's something called NF_Streamlit. So let me first of all share the link. GitHub.com. I'll put this in chat. Moco Makers, sorry, Moco Makers, Streamlit. All right, put that in chat. Okay. So for those who haven't used it before, GitHub is like the public place where you publish projects, code projects mostly. And there are nowadays private ones too, but pretty much if you're using GitHub, you're publishing something publicly. These are very common in the computer science. A lot of times what you'll do is you'll invent an algorithm, you will have a code base that does the algorithm, and you will publish it to GitHub, and then you'll get a link, and then you'll take that link and put it in your paper at the very bottom where it says additional data or resources, something like that. And you'll say, like, if you actually want to apply everything I talked about in my paper, just go ahead and download the code and modify it for your project. It's a very friendly and forward way to share materials. Projects have a conventional structure when you're building them out. So let me just claim some real estate over here at the side, and we'll kind of go through it. So when you have a project, what I'm talking about is that you literally have a folder, right? So my folder is over here on the right. I'll go ahead and just open it in Reveal File Explorer. So first of all, on my system, I have a place that I keep all my projects. This is a good idea for a coder. You just have that one place you go. There I have all of my different projects, and there is one empty folder that I create for what's going to be the code for the thing that I'm doing, the project I'm building. So this is when I'm talking about a project, this is what I'm talking about. I'm talking about the folder that holds your code. So we're going to start with your root level folder, root level project folder. Root is an operating system term. It means the highest level of a directory. Normally, like all operating systems have an absolute path root. So for example, in Windows, the C drive is almost always the root. In Mac and Linux, it's a slash. So like that's the root. And it's just the highest level directory you can possibly go. I'm talking about a relative directory. So the highest level directory for me is this Streamlit. I can go deeper than that. So here I'm in the apps folder. And so if you think about it relative to the Streamlit folder, I'm in /app, right? And so the app is a directory that is relative to the root project folder. So you have the root project folder. By convention, you're going to normally have a source code folder. So this was actually a very big surprise for me. Most of the project code doesn't just start at that project level, and there's actually a reason for that. And let's add some other details. What do you have then at that root level? Well, usually the most important thing that you have is a README, and a lot of times they're a .md, which is markup, which is just a way of formatting. So if you see here, there's like headings, bars, links. If I look at the edit for that, it's very human, but like it's technically like this is a heading level 1, this is a heading level 2. Links kind of follow this square bracket, curly bracket. I'm not going to cover it, but the syntax is called markup. Language. You guys can it's very, very common, and it's kind of like if you ever done HTML, it's like a even more minimalist version of HTML. But the idea here is that you have a README, and the purpose of the README, from my opinion, is a few things. First of all, basic summary. What is it? That's the most obvious thing. Everybody knows that. But the other things that I would say, that the next one that I think is most important is, as a developer, how do you spin up on this project? So you have to answer the question somewhere, how do you get started? And it is best practice to put inside the README in some kind of guide on, here's what you do. You have to install this, it needs these dependencies, this is the start script, run the start script like this. It can be very simple, but nobody knows how to start your project except for you. So giving some place somewhere how you can actually just get going with it, because a lot of times using it is the easiest way to learn it, and then like you'll go into the code after to figure out how it was done. But starting with just some basic quick start guides, really good idea. And then optional but encouraged, I think it is best practice to say, how can others contribute, get involved? So this could be link to URL or email, contact info, whatever it is. Just a way for some folks to, like, they really, really like it, reach out, get involved, support, ask questions, whatever it is. So that's the README. Now there are other things here. So let me go back to our applied example, and those start to get a little bit more situational. There is a git ignore file. We're going to get into Git very soon, which is version control. Version control is a way of tracking every single change you've ever made to your code. And so, you know, you write a title, and then you change a word, and then you change it again, and like you save different versions of that draft. Well, you can go back in time and say, I want to go back to like the second one I had, or the first one that I had. And so it's the ability to basically roll back your code to prior versions. So there's generally a full history each time that you kind of save it. And what they in Git, they don't call it save, they call it making a commit. So we'll get into this coming up very soon, but basically we're going to cover coming up how you have that history. You can see here there's a history here of every single change that's ever been made, even showing individual lines of what was added. The green is add, red would be remove. So there, on the left was the old version, on the right is the new. In this commit, they added these lines, right? So it's just this idea that you can kind of track how things have happened. So git ignore is going to be how we specify what you don't want in that history. These generally are going to be things that are changing every time you reload the page. So that might be like cache or session variables, you know, so anything that's like junk data that you just has nothing to do with the code of your project and is just kind of created dynamically on the fly. But it could also be things like passwords. So a lot of times you as a data scientist have to connect to a data resource, and that could be a database. It could be an API, which is a way of basically using URLs to send code back and forth or data back and forth. And it could be a number of things. It's just anything that you're connecting to that generally you have to log in. And a lot of times these logins are in a data file somewhere. And the idea here is that you have a file on your local computer that has all the passwords. And you then write a Python that says, open the passwords file, get me the password for database 1, and then log in. And at no time in your main script do you ever write that password down. You're just saying open it from over there and get it. Now, when you're saving your code publicly on GitHub, what you're doing is you're just saving the code that uses it, and you're not saving the passwords file. But perhaps in your README, you're saying create a file that has the password, and it should look like this. A lot of times you might even have like a template of like what the password should look like, but you don't put the actual password in GitHub. That's very important for your entire career working with data. Never add to version control any sensitive credential or password. I see it all the time. It's a huge deal. People can get fired, but also at least people have to change the password for the entire system, and that affects just you and just everybody else. It's a huge pain in the butt. So getting back to the structure now, so Git is, there's something to ignore files in the history. There's the README. A lot of times there is a scripts file. So scripts are optional, but what scripts do is they kind of run something as a one-off. So for example, run a one-off program. So this could be, for example, do a first-time setup, do a data migration, server A to B. Could be anything. It could be a something kind of supplemental, like do a code scan looking for code quality, right? It could be something like that, which they call a lint checker. And so basically this is not the thing you need for your code. Like a lot of the code we're going to look at are things like websites or maybe data processing notebooks, where like you have input at the start and like a figure at the end. But you have kind of these supplemental things that they're kind of more about the infrastructure or supporting tasks that you might do only once. Those would go into scripts. They're about the project, but they're not the core app. And then, the source is where the core code goes. And then there are other things here. I won't go into them too much, but you'll see like .github, then a /workflows. This is something specific to something called CI/CD, and what that is continuous integration, continuous development. And it's this idea that when I'm pushing my code to GitHub, there's a point where I've made a commit, I've made that save. I am now going to sync my version of all of my saves into GitHub. When that happens and like the push is made to the server, the GitHub itself can run a bunch of code that does things. And it's like, for example, a lot of things it does are those lint checkers, like, hey, you just pushed code, let me scan it to make sure there's no typos or any syntax errors. It could also be like, hey, this has no syntax errors, so let me take the next step and actually push it to the server, or do a data sync or do a database update or whatever the thing is. But it's basically, you can do these code actions every time you're pushing to the repository. And not all projects have that. They're a lot more common these days. This other one is just very specific to the type of developer environment that we have. So I won't cover that too much, but we'll get into that later. So that's the main thing that I wanted to cover, is basically you often don't have your project in the root level. It's often in a source. It can be called something else. In our case, it's actually called app. So it does depend on like Python, PHP, what framework you're using, what their convention is. But it's either called app or source or main or something. Like there's always you can kind of narrow in on which one has the code. So this code, let me start off by showing it, and then we'll get into what it's doing and a little bit about it. So first of all, let me kind of start over. Let me close this somehow. I don't know if you can close a project. Maybe over here. Well, let me do something else. Let me show you what you would be doing. So what you would do is you'd open a folder. So say this was a new project, right? Maybe we'll go through a little example here. I'm going to do new coder demo, right? And so I create it on my operating system, and then once it's created, I select it and open it as the main folder. Now you create it and it's here on the right, but there's no files. At this point, you create your files. So let me just start with a README and heading. This is a demo for Git usage. We'll add some details coming up later. And then of course, you create that app folder, et cetera, et cetera. We'll get into that coming up, but this again, we're switching from using Python command line, which is still important, and we're going to run it, but we're moving from Python script.py and like calling my script into using an IDE, integrated developer environment. So again, at this point, you should have VS Code installed. If you don't, please go ahead and get it. It's on all the operating systems. So let's go ahead and go to that project. NF Streamlit. All right, so again, I'm going to show you the project, and then we'll get into it. The details of how this works aren't very important right now, but I just wanted to show you kind of why we're doing it, what we're doing. So I'm here in the folder of the project. So all of my code, if I were to write ls, in this instance is list directory in PowerShell. You may recall I actually prefer, on Windows, I prefer command prompt. So let me switch to command prompt. If I do dir, you can see that, yes, I am in the Streamlit folder. Here's all my files, same one as over here. And what I need to do here is I'm going to change directory into the code one, the app. Dir, okay. Now inside here, I have a home.py. This is in the README, so I just know this. To launch it, I run Streamlit run home.py. Don't worry about running it yet. I'm just kind of skipping ahead to just running it, and I'll cover how to do that coming up. But basically what I'm doing is I'm launching the code. So now we're going from Python, and what I'm really doing is I created it right here, a server. So I've created a program whose job it is to respond to browsers. And how do browsers work again? You have a URL, you push enter, and it goes and it fetches something from somewhere. The where it goes to fetch is generally there's a URL part, and then there's actually a port as well, but they commonly don't show it to you by convention, but you can still add a port manually. Just kind of as far as like a FYI, when you go to, let's say, https://google.com, this HTTPS bit, it's the S is that secure. It means that you have an encrypted connection between your computer and their server. That's actually running on port 443. So it's the equivalent to doing port 443. 443 is a port that has that encryption. And basically what I'm doing is I'm going to the server, google.com, when I'm on the server, google.com, I'm saying, let me talk to a program that's listening, and specifically listening on a port numbered 443. The server could have many, many ports doing many things, but I'm only trying to talk to the one on port 443. At that point, it accepts our connection. We have a tunnel between our laptop and that server, and we're sending data back and forth over what's called a socket. But basically, it's just a pipe on the internet where the data is going back and forth. Now, in the old days, and you do still see it sometimes, especially for things like old federal files, and I don't even know a URL that has it, but there used to be HTTP without the S, and what that is it is port 80, and it's just the unsecured legacy how the internet used to be back in the 80s, 90s. It still works, but a lot of times what happens these days is they'll redirect you from HTTP to HTTPS, but some servers keep it at port 80. Go ahead, Anushka.
I left for a minute and I think I got a little lost. What are you? I know you were talking about like GitHub and how you can like use the code from there and like apply it to your project or whatever, but what are you showing us right now?
So I'm giving you foundation for I guess connecting to things. So what I have is I'm running a server. I'm trying to explain what is a server, how do you connect to servers. And I think the most important part is that there is a URL and a port, and the ports mean different types of connections. So the two that we've covered so far are, there's an encrypted
443 and
Mhm.
the old
Yeah,
80s or 90s one.
yeah. The
Okay.
old HTTP is 80, and they do different things, right? So literally, if you're on port 80, it is sending plain text. So if you were to log into Amazon.com over port 80, you would theoretically be sending your password, and then a server in the middle between you and Amazon could read that data and see your password. And that's why we switched to HTTPS. It creates a connection first. Once you have the connection, then you send the data. But the idea here, the takeaway is that they're two different protocols. And there are other protocols. Later on, you'll probably be required to work with a protocol called FTP, File Transfer Protocol. And it is commonly over port 20. There's actually a few different ports it could be under. But basically, I don't know if I have any of these. Let me try maybe this one. Maybe not that one. Let me try a different one. Let me do, oh, I know, Moco Makers. Good old Moco Makers. Moco Makers. Good work. Actually, maybe I turned this off. This is a bad example. Okay, well, let me just find a picture of it. FileZilla FTP. All right. So what you would have seen is, let me get to that image. Okay, you would have seen this. On the left is your computer. On the right is a server. You have logged into a server, and you can drag files from the right to the left or from the left to the right. This is happening over port 20. And it's this whole other way of logging in. There's different ways of doing it. I won't go into those details, but just start to get the idea that the way the internet works beyond just the browser in particular is that different things have different ports. And if you actually Google common internet ports and go to images, you'll see that a lot of these have been established a long time ago. FTP is this 2021. 80 is that HTTP we talked about. There's a bunch of other ones. You don't need to know them all. Just kind of you'll encounter them organically over time. In particular, databases have some standard ports. We'll get into that when we connect to our database. I believe Postgres is 5432. And then going back to our example, we are creating a server that has a port number that's 8501. What you should know about this is that this is a very high number. If you go back to the common ports, port numbers, they tend to end maybe about 2000 or something. Like they're just maybe even like below 1000. They just aren't that many ports that at the low numbers that are very common. It goes up to like maybe 2000. Beyond that, very rare. So what you're doing when you're creating a port that is really high number is you're finding one that nothing else is using. And so Python has started a loop of code. That loop of code is waiting for things to connect to it on this port. And it's an HTTP port, so it's just a standard, browser can access its style port, but it is still listening on this custom port. So the way it works is that basically when you're running when you're running stuff on your local system, so I am on my laptop, I'm having my Python on my laptop run a server. When you're on your own system, you can use this kind of shortcut called localhost. This is all laptops have it. Windows has this, Linux has this, Mac has this. Localhost means your local system. It also, by convention, just heads up, is equivalent to the IP address 127.0.0.1. That also means my local system. Now, if you're connecting to a Google server or some remote server, a lot of times what you'll do instead of an IP address is you'll have a URL like google.com. But what you need to know about that is that all URLs are just looking up on a public listing on the internet. What does that translate to as an IP address? So all URLs become IP addresses. And basically behind the scenes, all web traffic looks like this. There's an IP address that you're fundamentally connecting to, and there's a port that you're fundamentally connecting to. And all that is on the other side of that is just a program running in a loop, waiting to connect, waiting for any connections, kind of talking on that port number. So now if we look at what we actually have, we have a web page that is being created here. So if you look at the URL, it's http://localhost:8501. So we're running a local server. It's at my local IP address on port 8501. When I go to it, and I'm also just going to like the /root level of that, it's going here. Now there are links on the side. Let me go ahead and just show you some of the older work that we've done. This will take maybe a minute or so to connect, just because it's doing a lot of processing. Actually, I clicked on the wrong one. Let me open the other one. I wanted the older MIPE one. So this is a framework in Python called Streamlit. Streamlit was made by data scientists for creating really quick web pages that work with displaying data well. So they're for data people to want to do basically prototyping of interfaces and quick little applications. Writing it is very Pythonic. It's just very intuitive, simple Python code. But what it gives you is it gives you a bunch of these interfaces. So I won't go into this too much, but briefly, what we're looking at is the results of our original work on neurofibromatosis, selecting and looking at a specific compound. So in this case, we're looking at this compound here. All of the dose response curves are here. Like there was all the cell lines are here, including some of these are tumor, two are reference. And what you see is that there's just charts, right? And so we're turning what was originally CSV code, that comma separated values, we ran it through our algorithm. We calculated things like the dose response curves, upper lower asymptotes, and then now we're just showing it. And you'll notice that there's like interactive things I can do, like I can turn off these gray bars by clicking on it. All of that interactivity, I never wrote that. That's like, it just comes with the framework, that Streamwork framework. So the homework that we're going to get to later today is we're going to have you guys actually try and write a Streamlit app that does something with a data set. So that's what we're trying to build up to today. Just to kind of go through other things. So it has every figure you could possibly imagine: histograms, bar graphs, tables. Most of our results are tables, but fancy little color thingies. The interactive is built in, again, zoom, whatever, blah blah blah. Cool stuff. But this is what we're trying to do. Is we're trying to build an application that helps us process and visualize our data in a way that we care to show it. We know that when we get responses, we want to look at dose response curves. And so here, the gray line is our reference, and the red lines are the 4 tumors. And so to the bottom and left of the gray means it's working, and to the top and right means it's doing the opposite. So like whatever this compound is, in all 4 of the cell lines, we can just look at it and say, oh, it's actually making the tumor to grow, right? That's the opposite of what we want. But it's just, we're adjusting the visual to say something useful, basically for scientists, for that communicate something about our data. What those visuals are depend very much on the science you're doing, what type of analysis, but getting practice turning your data into figures is really fundamental to what we need to do. And that's something that we're going to try and work on today. So going back to the code, again, we have the stuff here. The thing that I was going to go through was kind of setting up a basic project with version control. So let me actually jump to this other project. And what we're going to do is we're going to use this to annotate things along the way. Important Git commands. So Git is version control, and you can run it from your terminal. So let me change to the project that we're in, cd project, cd coder or something, coder demo. We dir, it's empty, nothing there. Okay, great. All right, so well, actually, there's an app folder there and a README. All right, so the very first thing is called git init. So git is a command line. You have to make sure it's installed. So prior knowledge or prior work is make sure git is installed. Use brew for Mac OS. Use git for Windows that's the name of a project. And then use your basic installer for Linux. Use apt install or similar for Linux. I'm not going to cover this. Use ChatGPT to ask how do I install Git on my system. It'll take you through that. But you know, just install Git. Make sure you have it running on your command line. It needs to be available as the command Git Git on your command line. That's the requirement. So now the thing that we need to start with is git init, which is initialize. This initializes a project. So I'm gonna show you inside of our coder demo folder. There's the only things here now are app and readme. I'm going to run git init, and so it's initialized. It has now created a secret folder that is kind of grayed out, which is a .git. So we kind of covered this briefly. I will add it to our documentation. Make sure you can see hidden files or do stuff like I think ls-la, which will show the hidden files folders that start with a period. So generally, like these dot ones are hidden from you, but what's inside of them is your history of every change you've ever made. So right now we're kind of starting with nothing. There's no commits yet, but let's go through our first commit. So let's do a git status. Git status shows me that I have an untracked file. I have a README, and it's just it's not tracked. It's read. So the next one I'm going to do is git status. This shows all the status updates for your current code. Okay, so I have an untracked thing, so it's not yet saved, is what that's saying. It's also not yet queued up for saving. So the first thing I need to do is get it ready to be saved. Basically, there's this idea of tracking, which is when you make a save, you can pick which files you're saving, because you could be editing like 20 or 30. So maybe you only want to like save 5 of them. That's what's being tracked. And so the way you do that is by doing git add and then the name of the file. Or you could do git add dot, which adds everything. So the next one we're going to add is git add and then name of file.txt, or git add dot, and then the dot means add all the untracked files into tracking. So that's the most common one that we do. Like if we touch 100 files, generally we're saving all 100 files all at once. So let me go ahead and just do git add dot. Now if I do git status again, status, git status, we now see that changes to be committed. There is a new file or readme. Okay, so it knows that I want to save this thing. Now let me go ahead and save it. That's going to be creating a commit. Git commit minus m is a message, and then you put a little message, initial commit. So we'll add that here. That is git commit minus my message goes here, 50-ish characters. Just basically explain what you're doing so that another human could read it. Saves the saves a version of the code to your current branch. We'll get into branching momentarily. So git status, let me see. Okay, so git, what did I do? Oh, I modified readme again by adding that. So let me go ahead and git add it again, git add, git status. So the latest changes I did are there. Git commit minus message, updated the message. Git status, and we see that there's nothing to commit. Go ahead, Anushka.
Could you just scroll up a little bit on the yeah, I just wanted to take a screenshot to put it in the notes.
Sounds good. I will.
Thank
I'm
you.
planning on sending this as a documentation after the call.
Okay.
Yeah.
Okay, great. Great.
Yeah. But yeah, great idea. Never hurts to make backups. As we know, I've deleted documentation in the past, so we're not immune to issues like that. All right. So what I've done most importantly with this commit is I have created a save. And if you were tracking me, I actually created 2 back-to-back saves. One thing to kind of see your history is there's this command called git log, and it shows you your history in the form of commits. There was an initial commit, and then there was that updated message commit. What's important here about these commits is that they have unique numbers. This is a concept called hashing. It is actually important to know hashing. Let me see, online hash generator. I want to kind of quickly show it. So the idea behind hashing is that you can take large blocks of text and turn it into a small number. Let me take just all this text, okay? I'm going to say all of this gets reduced and it becomes this smaller number. And the idea behind hashing is that this hashing is this number will change dramatically if I update even a single character. I'm gonna replace this H at the top for a B, and then I'm gonna run the hash again. And it's this. Now it's this E5 number. Let me change this to again. Now it's an A1. It's an A5, 4, 9. Like these numbers are dramatically changing for even just a single character. So the idea is that this is basically a fingerprint for this file. And it's a fingerprint where you can't go in the other direction. I know that I can create this unique code from the text on the left, but I can't take the text on the right and regenerate the original. It's just kind of going only in one direction. But you can prove that this whole code would turn into this. And again, so it's a fingerprint. That's what's going on with version control behind the scenes. When you save a file and it says, hey, I notice you made a change, what it's doing is it's running a hash on the original, then you write your code, and then it checks it again, and the hash will be different. And so it's saying, oh my gosh, this fingerprint has changed. Therefore, you must have modified this file. And it does that for every directory and every file. It kind of builds like a tree of every directory. And so like some directories weren't changed. That directory will have the same fingerprint, but maybe this other folder did change something. So that folder has a different fingerprint. So again, like your whole tree of files and folders. You can have at each level a fingerprint per file, and then going up to the folders, the higher level folders will also, their fingerprints will change if anything below it changed. So that's kind of the theory with Git in particular. So what I've done is I have created 2 save points. Now, let me do something. I'm like, oh my gosh, I totally made a typo and I want to go back. What I can do is I can do git checkout and then the hash number. And if you notice what happened on my screen is we lost a bunch of text. So I updated every file in my project to represent the file as it had existed earlier in the coding. And so this is why version control in part is useful. Is if you make mistakes, you can go backwards. Now in this case, git log. Let's see. Did I lose that? I might have. Log. Yeah, I might have done bad practice and actually lost those files. Let me just go ahead and add that. So we're git init. Oh, I can control Z, so that works. Yeah, okay. So here's my code again. So at this point, if I do git status, yeah, let me go ahead and git add everything, git status again, just to see where I am. Okay, I've modified it. Actually, let me do something else. Let me do git checkout head git log. Yeah, okay, whatevs. All right, so git status. I'm just gonna go ahead and just continue like everything's fine. Git add everything. Git commit. I'm saving my change now. Added another line to README. Git status. Okay. All right, so that is kind of a little bit of version control. Now, there's one other level, which is that you are writing code on these commits in a sequence, but there's this idea that other people are also writing code. And so this gets into a concept called branches. And branches are basically the splitting and joining of sequences of code. And basically the theory is that as you're coding along, you're writing a feature, you're kind of doing a linear sequence of commits. At some point, you're going to merge your code into maybe the code on the server, like this. Let's say this is like our development server right here, our experimental testing server. So you're merging your code onto our testing server, and what's going to happen is that your code diverged at some point in time, at some place in history. Your code diverged. You wrote your stuff. Those things that you did are going to be saved as the differences from the prior versions. Let me show you what differences. What different. When I'm saying code is, we're saving the differences. What do I mean? There's a tool that you don't need to learn, but just know that it exists, called diff. So let's say that my original code was this on the left, and then I modify it. So I'm going to delete the heading, change this line, import commands. This is changed, and then add a new line. This is a new line. So this is me working on my project. If we run the diff tool, diff shows you only what's different about those text files. So the red, something was deleted. This, something was modified. And green, something was added. So this is what the Git is actually doing as far as saving your files. And this is actually, if you think about it, this is the smallest way you can save code changes. Like you could either save entire copies of file A, file B, file C, or you could just save file A and then change just the save just the line you changed going to B. It's really like this, you're just changing what's different about it. And at some point, when you're doing these branches and you want to merge back, you have an understanding of what the original was and what the differences are. And so you're basically applying all of those changes, all of the insertions and deletions, additions, on top of that original file and basically bringing it up to date with all of the changes you made. So that's merging the branches. I'll just briefly cover that. What I'll say is that the most important is actually just being able to work with Git to kind of download code. This stuff about like branches is really only if you're collaborating as a team. It may come up for us depending on like if we're releasing an app together by the end of the year. But if we're just coding by yourself, you don't need to do this. To create a branch, you would do git checkout -b and feature branch name here. So the -b means create a new branch, which starts from the current commit you are on. By convention, you call each change you make a feature, and this feature will be merged up into a develop branch and then a master branch. This is called Git flow. So the idea here is that every user, every human is probably doing their own little code, their own little feature. And then you're pushing it up to like a test experimental server, which is this develop branch. And then maybe 4 or 5 people have pushed to the develop branch. It has all these new features. We've all done quality assurance on this kind of test server. When we're ready to take it to production, then we push it up to the master server. So the master server would be the live public thing that the world can see. Presumably, we want to have that quality assurance step before that happens. That's why we have the develop server. So let me actually focus you in on perhaps the most important thing, to be honest. What you need to know is when you're reading a biology paper and it says, grab my code from GitHub, what do you need to do? Well, you'll go to GitHub. I recommend being logged in, but you don't have to for just downloading. There's always going to be this green button. When you're not logged in, it gives you this HTTPS link, which is perfectly fine, especially for just downloading. And if you are logged in, it gives you the SSH way to log in, which just means you don't need to enter your password. I'm going to do this one. That's the SSH. They work equivalently. So let's say that I want to download this code. Do not do the obvious thing, which is clicking this button that says download zip. Okay, maybe do that if it's just like for sure you're ever going to use it just one time. But don't do that, because what Git lets you do is keep this code updated. Keep in mind that these software is living. You'll see that 5 months ago this was updated. You might want the next version. By downloading it with Git, you get all of the history that ever was used on how it was made, but also you have the ability to fetch the latest version of the code and merge it in to your project. And that's the best practice. So what downloading looks like is git clone link. So this is the most important command for beginners. It is downloading a URL for, these are called repositories for a Git repo, which is shorthand for repository of code. You can also say that using the HTTPS version of the GitHub link is fine. It just changes how you need to log in when you are pushing up new code changes. And they both work, minor detail. All right, so git clone. Let's go ahead and do a git clone. So here I am. I'm in a project. I have. I'm just. Let me just go ahead and make a new dir. Make directory temp or something. Change directory into temp. There's nothing there, so I'm going to do git clone GitHub link. So what it's going to do is it's going to download everything. And then it's going to, when it says delta, these are all those little code changes. It's going to apply all those little insertions, updates, deletes. And now if I do a dir, I will see that it created a new folder that was the name of the GitHub itself. So this /nf is the name of the folder that we're going to do when we do the git clone. I can change directory into it. And I see I have all of my code that I can start to run, presumably. And I can also do things, because this is a Git repo, I can do git status, git log. Oh, I can see all the history, when it was last modified. Need to go back to prior versions, whatever I need to do. So that's really important. For the sense of completeness, I talked about creating a branch, but there's also this idea of changing branches. So that would be git checkout branch name here. So for example, git checkout feature, new feature. This form without the -b changes your branch. So again, this is if I had say so this is a big change, right? So if I go back to the top level of our Coder Dojo project, and I'm saying git status, what's going on? It says, well, yeah, I have this untracked temp folder I've never seen before. And by the way, you've also updated the README. If I create a branch, so I'm going to do git checkout -b to create a new branch, call it feature has repo git status. It says that I am on branch feature repo. I still haven't added the tracking yet, and I haven't added a commit. So let me go ahead and do that. Git add dot git status. I've now added everything. The dot is add everything. There's the file and the folder, and I'm going to do git commit message added repo inside feature branch. Git status. Okay, all clean. Git log. I see that initial commit, added another line, added feature branch. Now, let's say that in this scenario, let's say that adding that repo is this really experimental thing. I don't know if it's going to work or not. I was running a test. Turns out the test fails. I want to go back in time to this other thing. One way is to go back to an earlier commit, but the idea with these branches is that they're very isolated. So you could maybe even work on two projects at once, kind of separately. What I'm going to do is I'm going to find all branches. You can do git branch -a shows all branches. I'll add that here. Git branch -a lists all branches. Now I'm going to do this other one to change branch. So now I'm going to go back to the master branch. This is a branch that never had the repo added. So let me do git checkout master. Now my git status, and what it says is that the README has not been added. You imagine we're going back in time. The master never had the README added. So now git add just the README, git add readme.md, git status. And what's important here is that we're not on this branch, we're not adding the repo. Wait, what's going on? On feature on hold on, I didn't change the branch correctly. Git checkout master. Your changes, okay, will be overwritten. Yeah. Okay. Ignore that. That's saying that you've already made some changes to README and you haven't, and you're on this branch, and you're going to lose them if you change branches. And actually, that's okay. I'm going to do something just to kind of ignore that. Git status. All right, so now I'm going to do git checkout master. We go back in time, and we're going back in time, and if we do now git status, we see that the temp has not been added. So what I'm going to do in this case is paste the changes, get to the README, git status, just add the README. Now I'm not going to use dot because that would get the repo, and I'm just trying to do just the README file. Git status. Now I can do a commit just of what I'm tracking. Git commit with a message of adding README updates only. Git status. And so now I have a git status and I'm on the master branch. I still have things that are untracked, but we know that we're not trying to add temp. But if we do a git log, we see that we did add the README. So basically, at this point in time, we have two branches. The branches have diverged. One branch has the folder in it. The other branch doesn't. And I can kind of like code in both branches in parallel or back and forth. And if I need to merge things in, there are ways to do that. Those are kind of advanced coding topics I'm going to kind of breeze past just for a sense of completeness. I'm going to just add a few other notes, and I think we can kind of move on. Git clone is the most important because when you're spinning up new tools that you're finding in science papers, the most important thing is getting the code on your system so you can run it. That's going to be git clone. All right, the next one, just for completeness, let's do git pull. This is from the remote server GitHub. Pull in and download all of the latest changes to the branch I am currently on. So let's say that you have version 1 of the code on the master branch. The author 6 months later releases a version 2 on the master branch. You would want to do a git pull, and that will download onto your system the latest version of that code. And then there is, just to talk about merging briefly, when you do merge, the most common way to do that is going to be git merge --ff. Let me ask chat just to make sure I don't mess this syntax up. Git merge syntax fast forward. I think it's source destination, blah, 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 blah. Git merge, fast forward only. Okay, yeah. Source branch. Okay. All right, so it's git merge. Let's say it's a two-step process. So the first step is git checkout branch to be merged into. So I'm saying I want to merge my feature branch into my master branch. So change directory, or sorry, check out your master branch so that it can be merged into. When you're on that branch now, then you run this command. You're going to run git merge --ff, and then the name of the branch, feature branch to merge into current branch. And then just some notes, --ff here stands for fast forward merge, and it means take all of the linear history from the feature branch and add it to the end of the current branch. So pictorially, what we're saying is that you have a master that you took a copy of. You did a git checkout -b to create a copy of it and called it feature A. You then did 4 commits on feature A. Then you did a merge into master. You changed directory into master, or you did a checkout of master. Then you did a git merge fast forward. What it's going to do is going to take these 1, 2, 3, 4, and then just add them to the end of the last one. And so you're just kind of updating the history of master, kind of pretending like it was serial the whole time. That's the simplest way to merge things. It'll automatically try and find all of the updates, and it does that stuff for you almost always. So I'm gonna move on past Git. I think the reason that I wrote this down and I took the time to write documentation is that you don't need to memorize this. The best thing to do with version control is to have notes exactly like this saved somewhere on your system, open them up, look at them, and find what you need when you need it. So keep this as a constant reference for you. You can use this for years and years. This is a very standard way of working with Git projects. You just kind of, it helps to know the theory a little bit. And again, I think maybe like a YouTube video, Olivia, if you want to find a good YouTube video to put in our reference to supplement this, like something like a 20 to 30 minute YouTube video on Git, probably be plenty. But basically, just use this as a reference. How do you initialize? How do you clone? If I am making a commit, what do I need to do? I need to add the files and then save my commit. Stuff like that. Git log. Let me make sure I have git log in here. Let me add git log. But it just stuff like that. So commit, git log, CA history of commits. All right. So I'll make this code available after on GitHub, and you guys can try cloning it down, playing with it, etc.